Okay, so this is basically just a lab that we could do in the actual lab. And it's just kind of reviewing what we've already learned about the gas laws. So Charles's law, Boyle's law, Gay-Lussac's law, and then what you looked at today, which is the kinetic molecular theory. Basically, it's just talking about how particles of a gas move. Okay, and one of the main parts of it is that as temperature's increasing, we're increasing the speed of those particles, and so that's increasing the amount of energy that they have. Because remember, this is kind of like the little diagram that we looked at in the notes yesterday, or the little drawing. If I have a solid or a liquid and my particles are closer together, if I add heat, right, or increase the temperature, what's going to happen to those particles? Well, they're going to start spreading out and moving around quickly, right? So I basically can start off with like a solid or a liquid, either one really. And then I'm going to eventually turn into a gas as I'm increasing my temperature and when I'm adding heat. That what's happening is the energy in this overall system is increasing. Okay, so when my temperature goes up, my kinetic energy also goes up, right? Those particles are moving around faster. You can think about it, they have more energy, right? They're more energized. So that's basically what's happening when we pop popcorn. Okay, so this first part is you're just reading a little bit about popcorn, what makes it pop. Basically, that you have some water inside the popcorn, and what happens is that increase my temperature, like when you put it in the microwave and you start heating it up, that water is going to expand. Okay, it's going to start pressing. All those particles of liquid water are going to turn into a gas, and eventually it's going to pop, right? Pop that kernel open, and then you have popcorn. Okay, so usually there's about 14% of that kernel is water. Okay, that's like the moisture level. So the more water, if you think about the more water that's in the kernel, right, the more steam or the more pressure that's going to build up inside that kernel, so the bigger the pop is going to be, the bigger your popcorn piece is going to be. Okay, if there's a little bit of water, it's not really going to change the way that it's not going to expand a whole lot because it's just a little bit of water, a little bit of pressure. Okay, so it's all about trying to figure out what's the best amount of water in this kernel. So you just have a few questions just relating the reading to the popcorn. Okay, so this is talking about what happens to the average kinetic energy as you heat up the popcorn, right? So that's kind of just like my little drawing up here. What's happening to my kinetic energy as I'm adding heat, if I'm increasing my temperature. And then from the reading, you can get how is temperature related to kinetic energy. So like, for example, if I increase the temperature, what happens to my kinetic energy? If I decrease the temperature, what happens to my kinetic energy? And then we can talk about, well, are those directly related or inversely related? Remember, directly would mean that they go the same way. Increased temperature, increased energy. Inversely means opposite. Okay. And then number 3 and 4, those are pretty straightforward. What state of matter is happening, is changing when we heat up that popcorn kernel. What's happening to that liquid water? And then number 4 is just a review of these laws here. Okay. That's basically the 2 laws that are applied. All right, the last part is a little bit of experimental design. So I'll kind of walk you through just so you're not super confused. There's not a whole lot to it. It's pretty basic little procedure. Okay, so what we're doing is we have 3 different brands of kernels. We're just trying to figure out what % of that kernel is water. Okay, so what we can do is we can measure the mass of our kernel. So like if I was going to create a procedure for what I could do, I might say something like, mass the kernels. Okay, and then I'm going to obviously heat them up, right? So what's happening when I'm heating them up, remember, is that water. It's like if I have my little kernel here, right? That water inside is going to turn into, so this is my popcorn at the end, right? That water has turned into steam. So now there's no water inside because it's all been released as steam. Okay, so if I want to find out, well, how much water was in there to start, well, if I weigh mass the kernels at the beginning, once I heat them up, if I mass the popped corn, right, then I can see what the difference is, right? The difference should tell me the amount of water, like the mass before minus the mass after equals how much water that I actually have. Okay, so now I have some data here. I've collected some data. So I have it in my chart. Sorry, you can hear my child. I have it in my chart. So basically down here, we're just gonna finish collecting our data. Okay, I will be there in a second. So we have some the directions for how to do the calculations.
A green shiny thing fell off of a stone, and then Aphie came with it, and the stone went home and I like it.
I will fix it in a second.
But I don't like that.
So, sorry. So you have some calculations here that you can do. It tells you exactly what you're going to do. It's just like what we talked about right here. You're just going to take the masses, you're going to subtract them, and we're going to figure out how much water, how many grams of water was actually in each kernel. Then we're going to use this little calculation right here to find out what percent of that water out of the total mass of the popcorn was really there. So you're just kind of plugging it in. And then the last thing, your number 3, is kind of summarizing the whole process. What happens when I heated up the water, right? What happened to that liquid water? How did that change the pressure inside the kernel? How did that change the volume or the size of the kernel? Okay, and then number 4, we're just looking at using that ideal gas law. Okay, and we're just calculating like how much pressure was actually produced. Okay, so we have our mass of water. We need to turn it into moles. So remember to find my numbers of grams of water. That's going to be my molar mass. And then for part B, we're just plugging it into that PV and RT. So P is pressure, V is volume, my N is my number of moles, which I found right here, right? That's my N. R, remember, is this constant, and then the temperature, okay, that you're gonna have to convert into Kelvin, and we find our temperature up here at the top, the conditions for popping. So that table number 2, 225 degrees, tells me the temperature that I'm using down here. So 225 degrees Celsius. Remember, you have to add the 273 to get to Kelvin. Okay, equals your temperature in Kelvin. If you have any other questions, feel free to email me. Hopefully this little walkthrough helps you figure out a little bit about it. And I do apologize for my child who has